Good morning, all of you. First of all, you just let me know whether can you hear me clearly or am I visible to you? Means the video, both are clear or not. Just let me know this. Is the audio video clear? Okay, because here it is raining badly. Here it is raining badly since last 2 hours. So that's why I don't know what's the network. So that's why asking you. Yes. Priyansh Kumar is asking, sir, electromagnetism. Yeah, electromagnetism is totally out from the syllabus. And in our previous classes, we discussed about electromagnetism. But board has decided that electromagnetism will not be there. It's totally cancelled. It's totally cancelled. So now you do not have to continue with this electromagnetism. But electromagnetism we have covered in 3-4 videos, as you know. But now you do not have to continue this electromagnetism. It's cancelled. So where are the other students? Where are the other students? So from your syllabus of half yearly, electromagnetism is cancelled, and because board has cancelled this. Okay, electromagnetism and that transformer both are cancelled. Okay, from the syllabus of half yearly also I am cancelling electromagnetism and transformers. So no need to study that. Electromagnetism and this. No need to study that, right? But where are the other students? And what I decided today that we'll start revision. Yeah, we'll start revision. And as you have seen in the title of this video, today we are going to discuss about torque. Torque already we have done. Already the torque and the related numericals are done. But again, we'll go for a revision, a quick revision on torque. We'll see what is called torque and what are the numericals important for your field exam as well as your board exam. Okay, these things will be discussed. But I cannot see other students. Where are they? I do not know. Where are they? The students. Where are the students? So, so as you told that you can see me clearly, even I am also audible to you. Now, one more question to you, like one more question to you now. Like if I show you this, are you able to see it clearly? Like this. Like I'm showing you this. Okay. Just let me know whether is it clear. These things you can read or not. It's clear or not. Just let me know. Okay. Amisha Garbal is saying yes, clear. Okay. Okay. Fine. Very good. Very good. Yes, few responses I'm getting. They are saying that it's clear. Okay, fine. Fantastic. Okay, good. So, I can see very few are there. Very few are there watching the video. I don't know where the others. Okay. So let's discuss about torque. Okay. We'll discuss about torque, and after that we'll see the numericals, different numericals important for your half yearly exam as well as for your board exam. So first of all, what is called torque? Torque has got different name. The first name is torque. Second name is moment of force. Third name is turning effect of force. All these terms are same. What I said, the first name is torque. Second name is moment of force. Third name is turning effect of force. Okay. Like, say, you can see this pen, fine. So here, I am applying the force here, upward. Okay. I am applying the force upward. Or, or I am doing this. Okay. I am doing this or I am doing this. Fine. That means I am not applying the force directly. I am not applying the force directly, but I am applying the force which I am applying, the effect of that force is working here. Okay. Understood? The force which I am applying here, the force I am not applying directly. Understood? But the force which I have applied, the effect of that force is applied there. Understood? Like, say here I can balance it. Say I can balance this pen here. You can see the pen is balanced. Okay. Now an extra weight I am hanging here. If you hang the extra weight here, then you will see that, yeah, see, this is coming down. Okay. Without this weight, the thing is balanced. See, I'm taking another weight here. The weight I'm hanging here. And when you hang here, you'll see that it's coming down. Okay. Okay. Understood? So when you are placing a weight, you are saying that the portion is coming down or this portion is coming down. Means the force which I am applying here, the whole system is getting disturbed. Means the effect of force is working here. Means the turning effect of force working here means torque. Understood? The same way, if I hold it here, say the thing is not balanced. Okay, because I am holding it from here, the thing is not balanced. Now what I'm doing, I'm applying a force upward. See, I'm applying a force upward. Okay. So because of this force, again the system got straight. So the whole system got disturbed. Who has disturbed it? The force has disturbed it. But I have not applied the force on that. But the effect of that force has worked on it. That is turning effect of force. Understood? Turning effect of force. Very simple examples, the practical examples I'll give you. Like, say, you are taking a wrench. Okay, wrench, you know, by which we can open the big nuts or screwdrivers. Okay, by screwdrivers you can open the screw. Okay, or nuts you can open by using the big wrench. Yes, by using that wrench also, we are, say this is the screw and we are fitting the screw in that wrench, and after that you will rotate it. Okay, means you are giving turning effect. or say screw. Say you have got a screwdriver. Say this is a screwdriver. Okay, this is a screwdriver. Understood? This is a screwdriver. Now, in the screw, say when you are putting the screwdriver in the screw, after that you just rotate it. No, you just rotate like this. Rotate. Okay, rotate this. Means you are applying turning effect. Okay, you are applying turning effect of force. Now, say a water tap. Water tap. When you take water, okay, when you take water from the water tap, what do? You just rotate it. No, the tap, you just rotate it. So you are giving a force, but by rotating, that is turning effect of force. Okay, turning effect of force or moment of force or torque. Here in our syllabus, we will not discuss about that, will not do any numerical. Listen me very carefully. Here in this chapter, according to our syllabus, that screwdriver or water tap, those numericals are not there. The easy numericals are there. The easy numericals are of, say, this is a scale. You are putting weight here. Okay, you are putting weight here. How the thing will move, how this thing will move. These are the. Got it? But before that, I want to tell you, say, this is the pen. See, this is the pen. Okay. Now, if I put a weight here, the pen will go this way. Means this is anti-clockwise torque. Okay. It's experiencing a torque that is called anti-clockwise torque because the torque is coming down. This side is coming down this way. And see, just compare it with a clock. This is anti-clockwise torque. Okay. But when you are putting a weight here, this will come like this. That is called clockwise torque. Understood? So this is anti-clockwise torque. This is clockwise torque. When your pen goes like this, anti-clockwise torque. When your pen goes like this, clockwise torque. I hope you remember this video I shown you once. Okay, whatever I told you, I will draw it once. So scale, see here. Just confirm me once that are you able to see it clearly? Is it clear? Just confirm me once. See, this is the scale. This is the scale which I am placing on, an sharp object. Okay, this is the scale which I am placing on a sharp object. This sharp object is called pivot. Understood? This sharp object is called pivot. And see, on the pivot, the scale is there. Either the scale can come this way, okay, which is called clockwise, or it can come this way. It's called anti-clockwise. Okay, clockwise torque and anti-clockwise torque. Fine. So pivot, let us consider that the scale and the pivot is at 50 centimeter. Okay, pivot is at 50 centimeter. Pivot is a 50 centimeter means the whole scale is balanced. Whole scale is balanced. So this is 0, this is 100 I am taking. Here in according to our syllabus, class 10th ICSE syllabus, the meter scale is there. Meter scale. Meter scale means 1 meter. The length of the scale is 1 meter, 0 centimeter, 100 centimeter. Because we know that 100 centimeter means 1 meter. So we'll take a meter scale that is 0 centimeter to 100 centimeter. And we are placing the pivot at 50 centimeter. Okay, 50 centimeter like this. 0 centimeter, 50 centimeter at pivot, and 100 centimeter. Okay, this is the scale. This is the scale, right? Now, got it? Now, if I place, the whole scale is balanced now. Whole scale is balanced. What I'm doing, I will place a small weight. Say I'm placing a small weight here at 30, at 20 centimeter. I will show you at 20 centimeter. I'm placing a weight of say 10 gram. See, I hope you can see it clearly. I hope you can see it clearly. This is 20 centimeter. At 20 centimeter, I am placing a mass 10 gram. Okay, I am placing a mass 10 gram at 20 centimeter. Just because of this mass, the scale, see, this is the scale. Now, because of this mass, the scale will come this way. No, I hope you understood this. What I want to say you. So this is the scale, and because of this mass, the thing will come this way. No, because this side is getting heavier now. This side is getting heavier, so it will come little down. Understood? It will come little down. So because of this 10 gram, the thing is going this way. Now, can you answer me? We have already discussed. Can you answer me? When these things will come down, that means, you understood what I said? When the scale will go this way. Why? Because this things is heavier now. This side is heavier. Means the pen is, or the scale is experiencing a torque. Okay, the scale is experiencing a torque. Can you tell me what torque is this? Means clockwise or anti-clockwise? Say, because of this mass, it is anti-clockwise or clockwise? Ratul has answered, Rohit Prasad answered. Any other student? Which torque is this? Because it is, this side is coming down. This side is coming down. So this is, yes, this is anti-clockwise torque. Yes, this is anti-clockwise torque. Yes, correct. This way it is coming down. So this is anti-clockwise torque. Good. Now we'll calculate anti-clockwise torque. All of you listen me very clearly. In this exam, I will give, in this half-yearly exam, I'll give 10 marks from this torque. Okay, 10 marks will be there from this torque. Simple numericals. You understand today's class, see the whole class, watch the whole class today. You will get the the whole concept about this torque and numericals. You will get full 10 on 10 marks in half yearly. Okay. So anti-clockwise torque. Now, what is the value of that anti-clockwise torque? Anti-clockwise torque. The value of anti-clockwise torque is, what is the mass I'm hanging? The mass hanged is 10 gram. So we'll write 10 GF. 10 GF in this way. See, we'll find anti-clockwise torque equal to 10 GF, because 10 G is the mass, but here we have to convert into weight. What is the mass? 10 gram. We have to convert it into weight. So 10 gram will be converted into weight, means 10 GF. I'm writing 10 GF into distance. You have to write distance between this mass and the pivot. Distance between mass and the pivot. Distance between mass and the pivot. Now, come on, tell me, what is this distance? Distance between this mass and the pivot. What is this distance? Can you tell me? Yes. Ratul is wrong. Okay. Al-Kamil has given correct answer. 30 centimeter. Yes, Karan Mitra is also correct. Ratul Karmaka is correct now. Yes, 30 centimeter. Correct. Very good. So this is 30 centimeter. The distance between mass and the pivot is 30 centimeter because this is a 20. Hope you understood this, all of you. Very important. The distance between mass and the pivot. Mass is at 20, pivot 50. So distance is 30. Yes, yes. All are writing 30, 30. Very good. So 30 centimeter. That is 300 GFCM. All of you, I suggest you to write this way. Anti-clockwise torque. Anti-clockwise torque equal to 10 GF. This is 10 GF into the distance 30 centimeter. So that is 300 GFCM. GFCM. This is the anti-clockwise torque. Okay, anti-clockwise torque. Now, let us placing another mass here, which is say 15 gram. 15 gram at 85 centimeter. Say, this is 85 centimeter. At 85 centimeter, I am placing another mass, 15 gram. Okay, 15 gram at 85 centimeter. Now, the technique is when you are finding the torque for this, just forget about this mass. Understood? When you are finding the torque for this mass, torque for this, just forget about this mass. Okay, just forget about this. Okay, just think about this. Now for this mass, which direction the torque will work? Of course, clockwise direction. Okay, for this clockwise direction, the torque will work. See, for this mass, clockwise torque will work. This is clockwise torque. Okay, so let us find the clockwise torque. Clockwise. First it was anti-clockwise, now it is clockwise torque. See, and all of you, I suggest you to go with this process. Here I am writing anti-clockwise because this side is anti, that's why anti-clockwise. And this side is clockwise, so write clockwise this here. And after that, find the torque. So what will be the torque here? Can you tell me how to find the torque here? See the diagram? Can you tell me what will be the torque here? What will be the torque here? Can you tell me? Yes, yes. Al-Kamil has answered. Very good, Al-Kamil. What is that answer? Yes, 85 into no. Al-Kamil wrong. Al-Kamil wrong. Just check it once. Al-Kamil, just check it. Al-Kamil, check it. Ratul, you also required to check. Ratul, you also required to check. Like I want to say you, Al-Kamil, you need to check your answer. Nitik Dev has written 525. Amishakal has written 15 into 35. 15 into 35. Let's see. Amishakal, then who is Shampapal? Just write your name once. Shampapal has written 15 into 35. Rohit Prasad has written 15 into 35. Al-Kamil has written 15 into 75. No, Al-Kamil, no, not 15 into 75. Karan is writing 15 into 35. 15 to 35. Okay, that is Maitri. Okay, Maitri. Uh, Actually, the correct is see what is the technique to find the torque. The technique to find the torque is that mass. Here, mass is 15 gram. So you have to write 15 GF into the distance between mass and the pivot. That is the formula. The distance between mass and the pivot. What is the distance between mass and pivot? See, the distance between mass and pivot. This is the mass and this is the pivot. Mass is at 85 and pivot is at 50. So what is the distance? Distance is 35. So that's why I'm writing 35. So 15 into 35, that is 525. This is the clockwise torque. Try to understand, all of you. The formula is very simple. The formula is very simple. What is the formula? The formula is that weight into distance. What distance? Distance between the mass and the pivot. Mass and the pivot. Very simple formula. The distance between mass and pivot. Okay. So by this way, I got the anti-clockwise torque and clockwise torque. Both the torque I took out. Okay. Anti-clockwise torque and clockwise torque. Both the torque I have taken out. Now one more term. We have to find resultant torque. Resultant torque. I'll show you that. Resultant torque. Resultant torque means just minus both the torque. Understood? Resultant torque means just minus both the torque. What are both the torques are? Both the torques are 300 and 525. Say 300 and 525. So minus it. 525 minus 300 is 225. 225 GFCM. Now, which is bigger? Clockwise torque is bigger or anti-clockwise torque is bigger? Clockwise is bigger. So write clockwise in bracket. Clockwise. Like this. See. Like this. This is the whole procedure. If you have understood this, like half of the torque you understood. If you understood this much, then half of the torque you have understood. Okay. Clockwise torque, anti-clockwise torque. First of all, we took out anti-clockwise torque. Then we took out clockwise torque. And to find the torque, just weight into distance. Distance means distance between the pivot and the mass. Distance between the pivot and the mass. Distance between the pivot and the mass. This way we find the distance. So we took out anti-clockwise torque, clockwise torque. Then resultant torque we took out. Okay, resultant torque. After that, we have done this way. Okay. Hope you understood this. Hope you understood this. Okay. Now things will get little complicated. Fine. Next sum, I will not solve it. You will solve it. Next sum, I will just give you the diagram, then you solve it. I will show you the diagram, then you will solve it. Okay. This is the figure. Try to understand, all of you, and just confirm me once if you can see it clearly. See, this is the pivot. Hope you can see it clearly. This is the pivot at 50 centimeter. Pivot is at 50 centimeter. At 25 centimeter, 20 gram is there. At 70 centimeter, 10 gram is there. Got it? At 25 centimeter, 20 gram. At 70 centimeter, 10 gram. We have to find resultant torque. We have to find the resultant torque. To find the resultant torque, first we have to take out clockwise torque, then anti-clockwise torque. And then we have to take out the resultant torque. So this is the figure. All of you just draw this figure on your copy. Come on. On your physics copy, just draw this figure and solve it and tell me answer in the comment section. First, tell me the answer in the comment section. First. You have drawn? Hope you have drawn this figure. Now solve it and tell me where is the clockwise and anti-clockwise torque. I'm waiting for your answer. I will also solve it. I'll also solve it so that I can check yours. Come on, tell me. Okay, okay. You are giving answer also. First, the answer is given by Alkamil. Very good, Alkamil. It's he's writing 200 GF centimeter towards clockwise. Okay. Ratul is saying resultant torque is 300. 300, that is anti-clockwise. Rohit Prasad, 300 GF anti-clockwise. Maitri is writing resultant torque is 300 GF centimeter anti-clockwise. Priyash Kumar has also written that. Sorry, Priyash Kumar has written that. Karan Mitra has also written that. Good. Jasraj is writing correct. You all are correct. 300 GF centimeter. 300 GF centimeter is the resultant torque, and this is anti-clockwise because anti-clockwise is bigger than clockwise here. Anti-clockwise torque. Very good. Very good. Good. Tapobrata Ghosh has also given answer. Very good. Anti-clockwise. Yes. Correct. Now next figure. All of you just keep solving these sums. And you might have noticed that this time in half yearly, I have given you the project for your half yearly exam from the chapters which is required for half yearly. Intentionally, I gave this so that while making the project, simultaneously you will have the preparation for your half yearly preparation automatically. All these videos which I've given, those videos we have done in the beginning. So whenever you are going to make the project, you will have the revision of those chapters of half yearly. Got it? So in this way. So next question I'm giving you. Next question. The pivot is at 50 centimeter. The scale is 0 centimeter and 100 centimeter. At 15 centimeter, a mass is there. 40 gram. At 65 centimeter, a mass is there. 20 gram. At 85 centimeter, another mass is there, 15 gram. This is the figure I'm showing you. Just tell me what is the clockwise and anti-clockwise torque. This is the figure. 0 centimeter, say, try to understand, 0 centimeter, 100 centimeter. Pivot is at 50 centimeter. At 15 centimeter, 40 gram is there. At 65 centimeter, 20 gram is there. At 85 centimeter, 15 gram is there. Now, can you tell me what is the and resultant torque. Yeah, find the resultant torque and tell me the answer. Resultant torque. Resultant torque and tell me the answer. Hope you have drawn this figure. This is 65 centimeters, 65, 85. Okay, this is the figure. Tell me what is the resultant torque. Just tell me resultant. I'm also calculating. Uh, let's see what are the answers. Answer is Ratul has sent 575 GFCM anti-clockwise. Then Maitri is also saying the same. Rohit Prashad is also writing 575 GF centimeter anti-clockwise. Let's see other answers. Other answers. Others have solved or not. Let's see. Jasraj is writing 575 GFCM. Correct. Correct. Tapabrato is also writing that. Yes, correct. You all are correct. Those who have sent me the answer, Mritik Dev was also writing correct. So those who are giving the answer, they all are correct. The answer is 575 GFCM anti-clockwise, because I got the total anti-clockwise torque is 1400. Total anti-clockwise torque is 1400. And total clockwise torque is 300 plus 525. No, you have also got that. 300 plus 525. That is 825. That is total clockwise torque, 525. Now, if you minus them, we are getting 575. Yes, correct answer. Very good. All are correct. Now, see, in these two sums, the sums which I have given you to solve, in these two sums, we have placed the pivot at mid, that is at 50 centimeter. Okay, pivot is at 50 centimeter. I placed, okay, 50 centimeter. But now I'm going to place this pivot in different position. Okay, I'm going to place this pivot in different position. Means not at 50, not at middle. Understood? But before starting that, all of you just tell me your name here. Just type your name here. Fatafat. Just fatafat. Just write your name here. Jasraj. Jasraj. Then Maitri Ratul. Maitri Ratul. Maitri Ratul. Then Tapabrata Subhendu. Tapabrata Subhendu. Subhendu, then Al-Kamil, Amisha Mritik, Al-Kamil, Amisha, Mritik, after that Priyans, Sudipa, Rohit, Priyans, Sudipa, Rohit, after that Karan, okay, Karan, fine, thank you, thank you, thank you. Abhay is also there. Abhay. Okay. Okay. Fine. Okay. Fine. I've got. After that, Namrata is absent. Then Srishi Sharma is also absent. I'm not seeing their. I have not seen their name before. Namrata is also absent, and Srishi is also absent. I have not seen their name before. Okay, now let us move to the next condition. As I told you, that scale, on the scale, like the pivot is not at midpoint. Okay, pivot is not at midpoint. Okay, the pivot is not at midpoint. Pivot is placed some other point, like not at 50, maybe it's placed at 60 centimeter or 70 centimeter or 30 centimeter or 40 centimeter, like that. So in that case, when your scale is scale is not pivoted at 50 centimeter, in that case you will get an extra torque by the scale. Okay, we have to understand this torque first. 0 centimeter, 100 centimeter. Now I'm placing the torque at 40 centimeter. Okay, see this figure. See this figure, all of you. 0 centimeter, 100 centimeter. And pivot is at 40 centimeter. Okay, 0, 100, pivot is at 40. Now answer me, which side is heavier now? See, this is small. This is so big. This side is small. This side is big. So obviously the bigger side will be heavier. The bigger side will be heavier. So automatically you will see that the bigger side is coming down. So which torque is this? Clockwise or anti-clockwise? Yes, this is clockwise torque. So extra clockwise torque you are getting for the scale. You understood my point? First, like this is the scale. This is the scale. See, it is balanced at 50 because pivot is at 50. But if you take the pivot at 40 centimeter, then see, this side is this much, but this side is bigger. So this will become heavier. So like this, it will fall. So here you are getting a clockwise torque. You are getting clockwise torque. Got it? Now, instead of 50, if I take the scale at 70, see, at 70 it is. That means this side is bigger, means heavier. So you are getting, yes, anti-clockwise torque. So when your pivot is not at 50, your pivot is not at 50, that means you are going to get a clockwise torque or an anti-clockwise torque for your scale. And that you have to calculate first. And after calculating the scale, then see other masses which are fitted the way we have discussed previously. Okay, other masses, the technique will remain same. For the scale, if it is not at 50, then find out the clockwise or anti-clockwise torque. Got it? Clockwise or anti-clockwise torque. Now, just remember what I told you for masses. For those masses, how will you find the clockwise and anti-clockwise torque? To find clockwise torque, that mass, say mass is given 10 gram, we'll write 10 GF into the distance between pivot and that mass. Okay. But for the scale, to find the torque for the scale, how to find the torque? Torque equal to mass of the scale. Okay, mass of the scale into the distance between pivot and the midpoint of the scale. You understood my point? To find the torque for any scale equal to the mass of the scale into distance between pivot and the midpoint of the scale. pivot and midpoint of the scale. Understood? This way we have to multiply it and we'll get the answer. Understood? Like, say, this scale. This scale is not pivoted at 50 centimeter. This scale is not pivoted at 50 centimeter. That means, this means, this scale is not pivoted at 50 centimeter means here a torque you are getting. Now the question is that which torque I am getting, clockwise or anti-clockwise? See, this side is longer, means this side is heavier, means it's coming like this. That is, yeah, this is clockwise torque. So for the scale, I am getting a clockwise torque. Clockwise torque. And to find this clockwise torque, so I have to write clockwise torque equal to mass of the scale. Here, the mass of the scale is 60 gram. Mass of the scale is 60 grams. So I will write 60 GF into the distance between midpoint and pivot. What is the distance between midpoint and pivot? Where is the midpoint of this scale? See, this is 0, this is 100. So midpoint is at 50. Midpoint is at 50 and pivot is at 40. So 50 and 40, the distance is 10 centimeter. Understood? Midpoint is at 50 and pivot is at 40. So 10 centimeter is the distance. So we'll write here 10 and we'll multiply it. 10. So that is 600 GFCM. 600 GFCM. So just you have to remember these two techniques. Just remember these two techniques. What are those two techniques? For the masses, torque for the masses. How to find that? Mass into the distance between mass and pivot. Understood? And how to find the torque for the scale? Torque for the scale, you have to find the weight of the scale into the distance between midpoint of the scale and pivot. That much. If this theory, if you keep here, then you can solve any sums of the any sums related to torque. Any sums. If you just keep those two theories here easily. So I want to give you a sum. Just tell me what is the resultant torque here. I'll give you this sum. Just tell me resultant torque. 0 centimeter, 100 centimeter. The pivot is at 60 centimeter. Pivot is at 60 centimeter. Okay. And at 80 centimeter, I'm hanging a mass 10 gram. This is the figure. See, try to understand. All of you, this is the figure. So just tell me, what is the resultant torque here? Can you say it clearly? At 80 centimeter, 10 gram is there. 60 centimeter pivot is there. Okay, at 80 centimeter, the mass is there, 10 gram. So what is the resultant torque? All of you just calculate and tell me the answer. What is the resultant torque? All of you. Simple figure, simple sum. Just tell me the answer. Acha, Ratul has given answer. Okay, let's see. First of all, Okay, you give the answer. After that, I'll show you. Oh, one more thing I have not given you. One thing I have not given you yet. Mass of the scale I have not given you. That is required here. Mass of the scale is 50 gram. Mass of the scale is 50 gram. That I have not given you here. I don't know how Ratul has calculated this answer. Without the mass of the scale, I do not know how he has calculated. Mass of the scale is 50 gram. Come on, solve it. Maitri, where are you? Maitri, where are you? Maitri has given 1100 GF centimeter clockwise. No, Maitri, this is wrong. I have solved it, but I'll not show you now. First, you show me your calculation, your answer. After that, I'll tell you. Acha, Nitik has written 200 GF anti-clockwise. Okay, let's see other answers. Maitri is writing 300 GF anti-clockwise. Rohit Prasad is also writing 300 GF anti-clockwise. I'm not saying you now which is the correct answer. First, you tell me your answer. After that, I'll show you my answer. Priyansh Kumar. Priyansh Kumar is also writing that 300 GF centimeter, 300 GF anti-clockwise. Dev. Yes, 300 GF centimeter anti-clockwise. That is the correct answer. Correct answer. Yes. Because for the scale is pivoted at 60 centimeter. Try to understand from here. See, the scale is pivoted at 60 centimeter. Means this side is bigger. Since this side is bigger means this side is heavier. So heavier means this is anti-clockwise torque will work. So this is anti-clockwise torque for the scale. Anti-clockwise torque for the scale. What is the mass of the scale? 50 gram. I told you. So what is his weight? 50 GF into 10. Why I am writing 10 centimeter? 10 centimeter is the distance between midpoint and pivot. Midpoint is at 50 and pivot is at 60. Midpoint is at 50, pivot is at 60. So distance is 10 centimeter. 10 centimeter. So that is 500 GF centimeter. Now, for this mass, 10 gram, what is the torque? Clockwise torque. 10 GF into 20. 20 is the distance between pivot and this mass. 20. So 200 I am getting. So what is the resultant torque? Resultant torque is 500 minus 200. That is 300 GF centimeter. 300 GF centimeter is the resultant torque. And this is anti-clockwise because anti-clockwise is bigger. Hope you understood this. Hope you understood this. Okay. Fine. Now, so, and this portion will be continued in our next live session. Hope you got the idea. The idea I have given you before because I have shown you the videos related to clockwise and anti-clockwise beforehand. So now we had a revision on that, a quick revision on that. But few more difficult sums are left. These difficult sums will be discussed in our next live session. Okay. So this much for today. Fine. This much for today. So just write your name in the comment section and then you leave the class. Thank you all. Thank you. Just write your name in the comment section.
Oh.